Hi, this is my solutions to Advent of Code 2024. And since it's a December month, I decided to participate in Advent of Code 2024. What Advent of Code basically is, it has puzzles which can be basically solved in any language, C, C++, Java. I went to the Advent of Code's Reddit page and I saw people solving it in Google Docs and whatnot. So you can just solve it in any language, and I am solving it in C++. This video will contain a solution from day 1 to 7, what I did right, what I didn't do right, and then what can be done better. I'll go through the algorithm, and I have coded it in C++, and I would skim through how I structured my code and how I solved the problems and what can be done better. You can see I was able to solve all two parts for 5 days, and then for 2 days, since I didn't have a lot of time, I couldn't solve the part B, but I have the solutions for part B of both the days, day 4 and day 6 now, and I will go through why I couldn't complete it, and how I did it, and so on. So let's get started. Day 1, and day 1 was very easy because it was more of an icebreaker than an harder puzzle. Look, let's see what day 1 looks like. This question is pretty straightforward. What it says is you have a bunch of number on the left and bunch of number on the right. What it says is you want to take the lowest number of from the left and the lowest number of the right, and then find the difference between both of them, and then second lowest and the second lowest on the right, and so on, and then add up the differences here. I will link all the questions down in the description so that you can take a look at it. And this question is very straightforward. How do you do it? You can just sort this one out, sort the other one out, and then just find the difference of each and every number and then add up. The very interesting point which I noted in this advent of code is not just solving the problem, it's parsing the input. That's the most important part and the most interesting part in every question here. How do you parse the input? Let's take a look at the input of the first file. It looks something like this, and you get the you get the input of each and every problem, and you need to store it somewhere, and then you just need to parse this. You just need to parse it and then use it in your code. That's a bit tricky because now this question is parsing is very straightforward. You just need to loop through each and every one and space separate it and store it in whatever data structure you want. But in the future days, it gets a little tricky and how you parse. It's not straightforward parsing of data and then just storing in the variable, where sometimes you need to write few logic and make sure you just take the required parts of the data. So I think the question one is very straightforward. Question one is very straightforward. So you have a bunch of number 5, 6, 7, 8, 2, 1, 7, 3, 8, 6. So what you need to do is you need to take the lowest number in the first list and the lowest number in the second list and find the difference. You need to take the second lowest number and the second lowest number in the second list and find the difference, and so on, and finally add every difference together. How do you do it? Straightforward. You just sort this left the numbers on the left, and then you sort the numbers on the right, and then calculate the difference. Then if you sort the number on the left, it becomes 2, 5, 6, 7, 8, and then if you sort the number on the right, it becomes 1, 3, 6, 7, 8, and then you just need to find the difference. And the point to be noted here is you won't be able to identify which one is the smallest. Sometimes the number on the left can be smaller than the number on the right, and sometimes the number on the right can be smaller than the number on the left. So you need to take the absolute value of the difference and then keep adding them, so that you don't have to write the logic of finding the smallest number and the biggest number and subtract each other. So how did I solve part A? For day one, I had some time, so I just wrote comments for whatever I did. From day two, it's just chaos because just too much things to be done, and then the questions were too lengthy, so that I just wanted to get things done. So I didn't write a lot of comments in them. So the first interesting bit is parsing. So first I take the input of the file, and then it's first I take the input of the file, and then I would parse the input. So for each row we'll get two numbers, a and b, and then I push a into one vector and the b into one vector. The map bit I'll come to that later because it is needed for part B. And then I sort each vector, and then I take the absolute difference and sum together. And that's it. And then I print the sum for part A. So on part 2, okay, in part 2 you need to even this is very straightforward. In part 2, what they're asking you to do is you need to find the something called a similarity score. Suppose take a number 3 here. 3 has appeared thrice in the list B. So what you have to do is you need to multiply 3 and then the number of occurrence of that number. So take an example of 4. 4 has occurred once in this list. So you need to multiply 4 with 1, and 2 hasn't been occurred here. There is no occurrence of 2 here, so we just skip, and then so on. We just need to add the total. So how did I do it? So what I did is I just created a map, unordered map here. The reason why I created an unordered map in C++ is an ordered map will have a log and time complexity in retrieving data because it gives the result in a sorted order. Since I don't need a result in any sorted order or nothing, I just wanted to know the occurrence. So I'm using an unordered map which stores and retrieve data in O of one time. So what I'm doing is I'm storing the occurrence of each number in the right inside a map, and then I'm just going on checking if the number exists. If the number exists in the map, if it exists, it just multiplies with the count. If it doesn't exist, it just multiplies with 0, so the net will be 0, and then I just add the product. Very straightforward day one. So from in day one, what I learned is how do I parse input. This is a bit different from how I parse from day 2 onwards, but day 1 was basically about setting up the local environment for me, and then getting things done and understanding how AOC works. Now let's look at day 2 of Advent of Code. Day 2 is an interesting problem because the hard variant is interesting if you could identify the time complexity of the problem, because the worst case solution and the best case solutions are almost same, and it is determined by few breakpoints which you add here and there. If you can justify the reason why you are adding the breakpoint and how the time complexity changes because of that breakpoint, you are good to go. So this question, what it says is you'll be given a bunch of numbers. We consider each and every row as an separate. We consider each and every row as a separate entity, and then now we need to identify whether each row is safe or unsafe. What do they mean by safe or unsafe here is, if the number is increase, if the difference is if the number keeps on decreasing or if the number keeps on increasing, then they consider the number as safe, either increasing or decreasing, and the difference should be less than 3. If the difference is less than 3 and either it is increasing or decreasing throughout, then they consider it as safe, or else they consider it as unsafe. Let's take for an example. Let's check for an example. This row is considered unsafe because 1 and 2 it's increasing, and 7 it is increasing, 8 it is increasing, and 9 it is increasing. Every number is increasing, but the difference between 2 and 7 is more than 3, so we consider this as unsafe. And if we take the first example, or this one, 9 7, it's decreasing, 6 it is decreasing, 2 it is decreasing, 1 it is decreasing, but the difference between 6 and 2 is 4, which is greater than 3, so it is decreasing. This is a very straightforward easy problem, part A. You can solve these in this in two different methods. One straightforward method is by using something called as a monotonic stack. So see here, a monotonic stack is a special kind of stack which maintains its element in monotonically increasing or decreasing order. So if you put some values in the stack, same, take a stack. Now first let's take this example. First I will insert a value 7 here, and then when I am trying to insert a next value, I would look at 6 4 2 1, and I would insert every number here, and then when I am popping out from the stack, I would see the number is either continuously been increasing or decreasing, and you look at the difference as well. This is an overkill for this problem, even because the time complexity is the for the optimal solution, and this solution is the same, but the space complexity is O of 1 where you use and stack here, and for each row it is O of 1, and overall it will be around n square of space complexity, which is unwanted here. All you need to do is there are better ways to solve this, just using loop and then having a flag for finding whether it is increasing or decreasing, and you'll be able to calculate the difference. That's what I did here. What I'm doing here is, so I have a flag for descending order, and then just an OK flag if things are okay till the end, and I would take the difference between two numbers, and then I would apply the condition here that whether it should be decreasing or it should be in descending order or so on. If the first number is in descending order, then every number, the first pair is in descending order, then every other number should be in descending order or ascending order. Suppose you from 7 if you go to 6, it's in a descending, the value has been decreased, so that means the numbers which are gonna come next also the value needs to be decreased. So to make sure this happens, I have a flag here called DEC. So this descending order flag will make sure that the consistency of being descending or ascending is maintained, as well as I check this condition that the difference should be between 1 and 3, and then if doesn't follow this case, and then I just mark it as unsafe. If everything is fine, OK will be true, and then I would increase the safe count. I think this is very straightforward part 1, but part 2 is very interesting here. In part 2, what they say is, you take an example 13245. So in 13245 or 86441, this is a good example. So what you can say is from 8 to 6 it is decreasing, and from 6 to 4 it is decreasing well within the limit of between 1 and 3. But when it goes from 4 to 4 it is not decreasing because the difference is 0 here. And then from 4 to 1 it is decreasing and the difference is 3. You can notice that there is one particular pair which doesn't satisfy our condition, and other than that everything works fine. So now what they're asking in the part 2 is they need to identify they need to identify the total number of safe pairs, and the safety includes one pair which is not safe. So if a pair has one pair which is not safe, then and then the question asks us to consider it as safe and increase the count. So in this question, if I remove this 4 or the other 4, if I let's assume I remove this 4, and then the difference here is 2, 6 and 4 is 2, and 4 and 1 it's 3, so that this pair is safe. And it works if I remove this 4 as well. So in if we the question asks is if you can remove one element from this list and the list becomes safe, then consider that whole row. So the easiest straightforward solution is, because we have in part A where we have the ability to identify whether an row is safe or not. So in part B, the brute force approach is just to remove every element. Remove one element, check if the pair is safe. Remove the other element, check the pair is safe, and so on. So after removing the element, if the pair remains safe, then you can say that it is unsafe order. How do you do this? A slightly better approach is first identifying that whether this pair is unsafe or not. So from this example, I would from part A I would identify that this row is unsafe, and then after that I would go ahead and keep removing the values until I find this whole row as safe. So once I the better and improved approach is just identifying the place where it is unsafe, and then just start removing each and everything from there, and then check if the resultant row is safe or not. Suppose in the same question 86441, I've just identified this 4 and 4 is the problematic part, and then I can just remove this 4 and then check if this is safe. Yes, it is safe. Or it's an or here, because you can just remove any one of the element and make sure that it is safe, we are good to go. Or then if this is not, then check this one and then it says if it's not safe, then check for this 4, and if it says it's safe, and it's safe. So here one more optimization which you can do is to break when you find and pair is safe. This reduces a lot of time complexity here, because when you identify one single pair which is problematic, and then if you remove an element here, and if everything works fine, you can immediately break out and say it is safe, instead of going and checking the other numbers to look to check whether it is safe or not. This is the most optimal solution for this problem. The brute force is removing every element and checking whether it is safe, and a better version is removing just the problematic parts and then look and identifying it is safe or not. And the most optimal solution is identifying remove one element, identify it, and then break out of it. That will be the most optimal solution here. I would rate this. The part 1 is very straightforward and easy, and the brute force of part 2 is also easy as well. But this getting to this time complexity of n square is something. It's almost n square, because you are only checking one single pair, so it is almost n square. Coming to this time complexity is a little tricky, so I would rate it between easy and medium. It's not a medium problem. It's not the part 2 is not an easy problem. It's somewhere between easy and medium. Okay, now let us look at day 3 of Advent of Code. Day 3 question was also on an easier side. From day 3, what I noticed is the algorithmic thinking part is or coming to one solution is very easy, but implementing this is very annoying, and the problems which came after day 3, 4, 5, and 6 were mostly not difficult to crack, but it is a little difficult to implement. I won't say difficult, it is a little annoying. That's it. You just need to have a good implementation skills, and then you're good to go here. So what this problem says is you would be given a string, and then we should make sure that strings which starts with mul, and then inside a bracket you just need to multiply the two numbers. And see, you can see this here, this mul, but it has a square bracket in it. A mul which has an a round bracket and there is two numbers between them, then you just need to go and multiply two numbers and so on. Here the answer is 4 into 2 8 plus 5 into 5 25 plus mul of 11 into 8 88, and then 8 5s are 40. Then add all of them together. This is a very straightforward implementation, and how I solved it is I will go and search for the first mul, mul, open bracket, and then if the string has this combination, I will go look out for the values inside it. It should have one single comma and then two numbers, and then a close bracket. I will go look for this combination of one single comma, two numbers, and then a close bracket. If this satisfies, I will just go multiply these two numbers and then add it to a result. And then I will keep continuing until I find the next mul. Check for a comma, two numbers, and then a close bracket, and then so on. And then finally, I would just add on all the result together, and that will be my answer. So let me show what I have implemented. So from day 3 onwards, I started organizing my code a little better. So what I would do is I would parse the input separately, and then I would create smaller functions so that it will be easier to be called in both part A and part B. And then I would write part A in separate function, part B in separate function, small helper functions to solve part A and B, and so on. So you need first I would just loop through it, and then retrieve all the content as string here. So each line is an separate string, and then I would return the string here. See, here what happens is we will just have one single line. Can just see the input is just one single line of a long string, and then you just need to identify the patterns here. So as part of implementation of part A, what I did is I'll just go look out for the mul. I'll just go look out for the mul open bracket. If I am able to identify the mul open bracket, and then I will go and call this function parse mul. What this parse mul does is it's an helper function which just identifies since we have mul open bracket, all we need to do is we need to have a number 1, a number 2, and then a comma, and then a close bracket. If after finding this mul open bracket, I'll just go look out for these other elements, and then once I get the other elements, I'll just multiply these two numbers and then return the answer. So what I'm doing here is I'll just here what I'm doing is I'm considering for negative numbers as well, and then if a number is negative, and then I continue incrementing. There should be only one comma and then digits. If there is anything other than one comma and then digits, then I would straight away return false and I would continue. I'm identifying two numbers here, number 1 and number 2, and then I'm multiplying both the numbers and then returning it as result. So what I'm doing is in C++ you can just return one value, either true or false. So I'm just passing this result as reference. So when I multiply the two numbers here, the overall result value changes. Thus I would get the actual result here if it is true. And then after finding a result or after something fails, I will just go and look for next m, which is an optimization for this problem, because so here in this input, let's assume you go and identify something like this one. Yeah, mul open close bracket, mul open bracket, square bracket, mul square bracket. And what you have to do is you exit out of this place, and then you can keep continuing to move forward until you find the next m. Because until we find m, we don't have to look for a substring which has mul, right? So the substring is a little costlier, is a bit costlier. Thus, what I'm doing is I'll just iterate until I find the next m. Only then I will go look for a substring of mul open bracket. I think that's the optimization I have added here. The time complexity would be around O of n, and it'll be even it'll be around O of n. That's it. And for part 2 is a slight variation of part 1, where what they say is they will have two more group of characters called do's and don'ts. If you have a do in the front, like if you have a do in the front, you will multiply the number, and if you have a don't in the front, you won't multiply the next result. So how did I do that? It's just the exact thing which I did for part A. While now I'll have two flags for do and don't. If there is a don't flag and I find some mul next, I just continue. I don't even go and calculate the result inside it, because it doesn't matter for me. So I'll look out for the mul and then I would continue. If there is a do, and then I will just multiply it. So there is a flag called do flag, and then I would look for don't or do. If there is a do, I would set this to true. If it's a don't, I would set it to false. And then I look for a substring which has mul open, and it should have a do flag. If it doesn't have a do flag, I will just continue without parsing the value. So this is my implementation of problem 3. I would rate this as easy because there's nothing hard. The logic is not hard to think, and the implementation is also not hard to think. So day 3 is an easy problem. Now let us see what's there in day 4. So day 4 is the first problem of grid in this advent of code. What I noticed is this is a very straightforward problem, but it needs to be implemented properly. You can if you look at this problem, what it says is you need to you need to iterate through the letters and identify all the xmas in the word search. The word search can be in left, right. The word search can be in any direction. Like for example, there is an xmas here, There is an Xmas here. There is a where can I find another Xmas? There is an Xmas here. Okay, there's an Xmas here. No, that's not the one. There's an Xmas here. An Xmas. Oh, I couldn't find one. I am just bad at word search. So you get it right. You can traverse in all 8 directions here: left, right, up, down, and 4 diagonals as well. You just need to identify the number of Xmas here, and then return the count of Xmas. The logic is very straightforward. You just need to go and find on each point. You need to traverse all the 8 directions and then identify the Xmas. A little better approach will be just identifying the first X, because every word needs to start with X, right? Because we are finding Xmas, and then in word search the first letter should be X. So identify each and every X and then traverse 8 direction, which is a far better approach. Another approach will be in implementing it. Because there is no other way you can just solve this. You just need to look at all the directions and identify the Xmas here. But the implementation can be done in many ways. The first way is if you identify the X, you can traverse to 8 directions by having a flag of directions. So like example, I just tried implementing it for this sake of video. You just one important thing about grid traversal is knowing where your boundary is. You can't cross your boundary because suppose you have an 3x3 matrix or a grid here. You can't go to an I and j. You can't go to an j which is over the limit, or I which is over the limit or above the limit whatsoever. You can't cross this boundary. Two ways to identify a boundary. One is to write a boundary check like this, and you should always look for a number which should be inside this grid. That is, I should be greater than 0, I should be less than the row count, j should be greater than 0, and then j should be less than the column count. Or else another way is you can add something called padding. That is, add some random characters over the boundary. Like you can add an asterisk here all over the boundary. And when you traverse, if you notice an asterisk or some other character which is not in that question, because sometimes the question might have an asterisk here or something, should make sure that the character which you choose is not there in the question, and it has no relevance to that question. So you can just add the padding all over the places, and then you can see if you reach that character, and you can say you hit the boundary, and then you can come out of it. And the better approach for direction, and you can use it everywhere, is having a direction vector. So let's take an example here. So from here, if I need to traverse left, I need to subtract j by 1, and then I will hold the I as the same value. If I do an I minus 1, if I do an I j minus 1, I would reach this place. If I do an I minus 1 j, I would reach this one. And if I do an I j plus 1, I would reach this one, and so on. You can traverse 8 directions by manipulating the I and j value. which I've stored it here. So 8 directions, if we just change the I value, you can traverse through all the 8 directions here. This is a better solution if there is just 4 directions, but since 8, I have written all 8 directions here. Why I am iterating thrice is because Xmas, I need to look out for boundaries 0, 1, 2, 3. So I am just adding a 4 characters here to just go to the next X or something. So for usually people would do -1, 0, 1, 0. They add direction. They determine directions by adding 1 to it. And since our problem wants us to know the exact string of Xmas, I'm just doing +3 or -3 here. So the part 1 implementation is I just iterate to each and every grid. So let's first look at how I parse it. So what I'm doing is I'll get each line, and then for each line I'll push it into an temporary row vector, and then I push that into another vector, so that we have a 2D vector here with each row of characters. This is a very huge input. Okay, then after parsing the input, I wrote an helper function which validates whether it is going out of bounds or not. So how do I validate this? I will check if that I value should be greater than 0, I should be less than row -1. It just needs to be here. I should not go here, or I should not go here, and j here and here, so on. So I would make sure that the boundary it stays inside this boundary with the help of this valid boundary helper function. And what I do here is when I identify the first X here, now what I need to do is I need to go to all 8 directions. How I do is I just traverse through all directions, and from that current position I just add the directions here. Suppose if I am 0, 0, I just subtract 3 and add 0, so that I would just go to that place. Suppose I am here, if I subtract 3i, I would reach this point, and if I add 3, I would reach this point, and so on. So I would for each direction I would check if it is invalid Xmas. How do I check this? It is very simple. You know 2 points here, that is a point A where it starts with X and another point which is supposed to be S. You need to check if this X, A, M, S satisfies. That is, you know 2 points here, you need to check other 2 points are A and M. That's what I'm doing. For each point I am since I know 2 boundaries, now I need to traverse from the first boundary to the second one, that is from X to S, and while traversing each character I would check whether it's there in a valid boundary. If it is a valid boundary, I would check for I would create the characters, that is X, A, M, S. I would create something like this, and I would check if it matches with our Xmas. So I am adding on the value here, and then if that string matches with Xmas, I would return true. So what I'm doing is I'll identify the step count here. I need to move one step, and then I would increment I and then j. Suppose if I need to increment this by 1, I would add this to the old one. If I want to increment j, I will just add that to the step count, and then after finding the new I and j, I would make sure that it is inside the boundary. If it is inside the boundary, I would just add it up to a result, and then I would check if it is equal to Xmas. If it is equal to Xmas, I would return. And the second part is a small variation of the first part, where now you don't have to go through all 8 directions, and you just need to go, you just need, what the question says is, here you need to identify the count which matches this pattern. That is, it has an M A S and then it has an M A S. So it just needs to match this pattern. How do we do it? I'll just identify the number of A's here, because A is the center point here, and then I would move in 4 directions to identify the corresponding characters. And here the direction is very important. If you do a -1 here and reaches this sum, the next direction should be +1 to reach this, and adding all these 3 should be an MAS, because we don't want something like MA, M, M, S and so on. So we need to make sure that this direction is first added and the result is MAS, and then we go through in this direction to get a result as MAS, and you just need to add the values. I would rate this question as a medium question, because you need to know how to implement it. You need to understand the boundaries, how do you calculate the boundaries and so on. So I would rate this as a medium implementation. Day 5 of AOC. This is a breather from a difficult day 4 problem. So day 5 was very simple. So what they're asking to do is, there is a bunch of lists here, which is the page ordering. That is, always 47th page should be before 53rd page, 97th page should be before 13th page, and so on. And then there is this list which is given, and we should make sure that it is in the proper order. That is, take 75 and 47. 75 should be before 47. Just look for 75 and 47. You can see this 75 is before 47. Then this ordering is right. Then we look for 75 and 61. 75 and 61. You can see 75 is before 61. And then you look for 75 and 53. 75 is indeed before 53, and 75 and 29, and so on. Then you look for 41 and 61, 41 and 53, and so on. Here you don't have to look in the reverse direction, because it is obvious that you are traveling from left to right, and it would for sure be in the right order, else we wouldn't have reached 47. Suppose, for example, 75, 41, 61, 53, 29. You don't have to go in the reverse direction, because else you would not, if the ordering is not right, you wouldn't have reached 61. That is, suppose if we would anyway look for 75 and 61 combination, and it would be true, only then we reach to the next number of 41, or and then we would look for 41 and 61. It has to be true, only then we have reached this number 61. So we don't have to go look in the reverse direction that the ordering is right. We just need to traverse in one direction, and the time complexity is n square here. So how did I do it? But the approach which I followed is, I stored all these as strings in a map. So we have a map here with a string called 75, 47, and a map has all the numbers as string, 45, 47, 53, and so on. So what I do is, while I look through this number, and I recreate this string, that is 75 41, and I would look through the map whether this number is there or not. If this number is there, then the ordering is right, and then I will return true. If the number is not there, if the string is not there, I would return false, thus the ordering is wrong. So the overall time complexity is O of n square, and the overall space complexity will be this creating this map for part A. Let me show how I implemented this. So while reading the file, I would create a map of this input and and I will set the value as true. Thus, I'll have a map with all these values, and the key will be these values, and the value will be a true. And then this is the important part in parsing the logic. So you will have a string single text file with these values as well as the question which we need to check for, and we need to first store these things differently. That is, we need to store the values in map, and we need to store these values in individual vector and then put it inside an vector. So what I'm doing is, while if I encounter an empty line, then I would know that I should stop adding things in map, and then you start adding things on vector. So until I reach the first empty line, which is this one, I would be adding values inside the map, and the moment I reach an empty line, on the next line onwards, I would keep adding it in vector. So the part 1 implementation is, I will just create a string out of the numbers, and then I would check if it's there in the map or not. If it's not there in the map, I would immediately break out of the map, and if the map is true, I will just what the question asks is, if the map is true, you should always pick the median and then just add them together. You should pick all the medians and then just add the medians together. So it just identify the median here, and then I am just adding it to the answer. So let's see what part 2 is. Part 2 is a little interesting here, because what it says is, for every here the line 1 is correct ordering and so on, but there would be few lines which is ordered incorrectly. So what the part 2 is asking us to do is to order these incorrect vectors into a incorrect list or vectors or a bunch of numbers to correct order. You can see 75, 97, 47, 61, 53 is been reordered to 97, 50, 75, 47, 61, 53, because our list says 75. Our list says 97 should be before 75, whereas the input 75 comes before 97. So we are swapping these two positions, and then the ordering is right. How do you go about it? Let's see, we have 75, 97, 47, 61, 53. It's exactly same as what we did in the part 1, but there's a small twist in this. So now when I look for a pair here, what I do is, in part 1 I would make sure it is there in the map. If it's not there in the map, I would break out of that loop. But here what I'm doing is, if it is not there in the pair, I would swap these two numbers 97, 75, and I would start looking for the pairs with the swapped numbers, because only this makes sense. And suppose there is one 32 here, and our pair says 32 should be before 97, then obviously 32 will be before 75 as well, because if you see here, 75 is before, because 97 should be before 75. So A equal to B, B equal to C, then A equal to C. We just use the similar property here. That is, after swapping the number, it becomes 97, 75, and then I would keep looking for a number which is in wrong order with the 97 here. And then if there is no number with and every number is in the right order, and then I will go for 75 and start looking at the other numbers here. If there is a change here, then I would swap the two numbers and I would continue with the latest swap number with the other numbers, so that the ordering will be right. Then after ordering, we just need to take the median of the ordered number. If the list is correct by the without swapping any numbers, and then we don't consider it. If there is some mistake in the ordering, and then we will reorder the number and then pick the median out of it. This idea is a little non-intuitive, I guess, of just swapping each other. But the way I came up with this is by thinking it as a book, because ordering of the book is always the same. Once you've given a certain order, the order won't change. Thus, I would just the ordering would be the same. So with that, I came up with this approach that once if we swap a number, that number should always be before the other numbers, and this property would always be true. That is, A equal to B, B equal to C. Then A should be equal to C as well. Similarly with the directions also. If it is less than, it just works the same. So regarding my implementation, so here what I'm doing is, if it's not there in the map, I will just swap the two numbers and I would keep moving forward. And then I would then just finally add the median after swapping all the numbers. I would rate this problem somewhere. The part A is very easy, it is an easier problem, and the part B is somewhere between. I think it is an medium problem. Okay, day 6. I think in day 6 is the hardest problem for me in this whole week, because the implementation was a bit difficult. That too, especially part B, and optimizing it to just run this huge input was very difficult for me. So what this question says is, the asterisks here are gods here, and we are starting at a position here and always facing up. What we need to do is, we'll just traverse in the direction which we are starting. We are in the upwards direction. The moment we reach an obstacle, we'll just turn right 90 degree. We have an obstacle here. So we just start here. We'll the initial direction is he is facing upwards. So we just traverse upwards and we reach the first obstacle. The moment we see an obstacle, we will turn right. And then there is another obstacle, we'll turn right again. Now we are moving downwards and there is an obstacle, we'll turn right. Another obstacle, right. And so on. Another obstacle here, right turn. so on here, and then finally we are exiting here. So we just need to count the number of steps he is taking to exit here. How do you do it? Initially is in upwards direction. We just need to always right turn and change the direction here. So there are two ways to do it. Way number one is having a flag for direction. So initially he is up. If he is up and he sees through an obstacle, he will turn right. If he is right and he sees through an obstacle, he will move down. If he is down and he sees through an obstacle, he will turn left. If he is left and if he sees an obstacle, he will move up. And the cycle will repeat. If you could store a flag of all these things, you can just solve this problem, and that's how I did it. There's a better way to do this, which I didn't think of at that time, and and that idea came to me after I submitted the solution, which I will discuss a bit later. So what I'm doing is this is a very bad approach actually, because the implementation is even though it is very simpler, the implementation is a little longer. You can see I've written almost 300 lines, which isn't that long, and I did it in a wrong way. So there is something called a new direction here, and I will pick the current direction. If the direction changes, and then I would return the newer direction here. So the things are same as the problem 5, which is boundary checking. For any grid traversal, boundary checking is a non-negotiable here. And here the difference is the moment we reach when the moment we exit the boundary, the problem is over, and we just need to count the number of steps. So what I'm doing is let me see here. So part 1, what I'm doing is I'll just have the position of where he is starting here, and then I will start the traversal from here. Like usually how we do it in a grid traversal problem, we would usually start from 0 0 and move forward, but here we are not starting at 0, whereas we are starting at the position where we want to where we are standing, and the direction would be upwards by default. And then how do we exit the condition? We exit the condition if we exit the boundary. So here so we write so I wrote a function called isExist, which will make sure that it is in it will tell us that whether we exited the boundary or are we inside the boundary. If we exited the boundary, then the problem is over, we exit the loop. Else we look for an obstacle here. If there is an obstacle, then we change directions here. Based on the directions, the I position or the J position would change. Suppose if we are traversing upwards, and then we find an obstacle. Now what we need to do is we just need to increment the I position so that he keeps traversing in the right. Sorry, we need to increment J position such that he is traversing the right, and the I will remain same. So that's what I am doing here. If the current direction is up, I would get the new direction. I would keep incrementing the position, and I would continue. If the direction is down, I would change the position and continue. Here I have interchanged between I and J, but you can just rename it. I just considered J as I and I as J, thus I am incrementing I and decrementing I. But it's the other way around. It should be J and then that should be I. Just the naming. And then the moment I incremented it, I just continue moving in the newer direction. So what I'm doing is, so the question asked me to find how many steps I have taken. So for every successful step, I would just mark it as X. And then finally I will just loop through and and then count the number of x. So here I would just mark each and every time I do a successful movement, I will just mark it as x, and our matrix will have a bunch of x after we exit. Something like this. So after that, I would just loop through and count the number of x, and that's the answer. You can just you don't have to loop through actually. That is on while incrementing, you can just increment the count and then just come out. But I just wanted to loop through because this is and key for our problem B, because we need this result to progress in problem B. That's why I did it that way. If that's not the case, you can just every time you increment, you can increment the count and then just if you break out of the loop, you can just return the count. Problem B is the trickier part here. It is very hard for me to run this large input, because the input was too large and it was very process intensive, that it was very difficult for me to run the test case. But I was able to pass the sample test case which is here, but the bigger test case, it took a lot of time to run the code. So what he says is, this is the path in which we travel, but what he says is you need to place obstacle in certain places such that it just stays in a loop forever. Suppose take this example. This is the starting point and he goes here, comes back, comes to here, and the moment he sees an obstacle, he turns left. So what happens is he just crosses here and then move forward. Instead, if we just place an obstacle here, what happens is he would forever remain in a loop. You just need to identify how many obstacles you can place such that you can keep him in loop forever. Suppose there is another place here where you traverse first in this direction and then the direction above this one, and then finally if you just place an obstacle here, he will forever be in this loop, and so on. How do you do it? The first thing you can do is you can place an obstacle on every position and then just make sure that this runs in an infinite loop. The better approach will be to just identify the paths in which he travels and then just add obstacle in every places in which he travels, so that you can skip all these places and just focus on the X marks. Place an obstacle in X mark, see if it is staying in an infinite loop. If it stays in an infinite loop, then come out of it, mark this point as an obstacle, and then increment the count and then continue. How do you identify whether the point is that we are in an infinite loop? You can't run this forever. That is, you have a path here and you can't run this path forever to make sure that it is an infinite loop. There is two ways you can identify whether this is in an infinite loop. Just take the worst case scenario of n cross n and see if it loops through these many times. You would most probably see that if you just reach this count, then suppose you loop 100 times, we have a 10 cross 10 board, and then if you loop 100 times over the small square, definitely you might you'll be for sure that we are in an infinite loop. But there is a better approach to do this. The better approach is making sure you store the direction along with the path. Suppose you go in this path and you are in that upwards direction. You come in this direction, you are in the right direction. You come down, you are in the left. You come on this direction, you are in right. And the next time you go in this direction, you are again in the upwards direction. So this upwards direction plus the points are matches. Thus you will be sure that you are again going in the same loop. How did I store it? To make things clear, let's take an example. In the first example, I keep storing the direction as well as the path here. We have placed an obstacle here, thus it will start going in the same direction as well as the same path. Because if you aren't marking the direction, you have if you aren't marking this direction, that is up and then this point here, the moment you reach the same point here, you will know that you have two possibilities. Either you can go up or you can go left. So if you are going in the left, that doesn't mean you are in a loop, because you are in a loop only if you go back again in the up direction and so on. So that's the reason why I am storing the direction as well. So when I reach this point where I am going to go upwards, I know that I have been through the same path and I did the same thing of going up. Thus I would identify that I am in a loop. It is a little confusing, but if I show the implementation, it will be clear. So in implementation, I have so for path B, I am using a set which stores the path as well as the string. The string is the direction here. So every time I keep updating the set here with the path as well as the direction, and when I reach this point where I'm again gonna go in the same loop, I will check that whether this point as well as the direction is there in my set. If it is there in my set, then that means I have already traversed in this direction. Thus I would mark it as loop and then I would exit. You should always make sure that suppose you mark this point as an obstacle and you identify that there is a loop here with the help of our set. The next time when the moment you break it, you should again mark this as X, so that the whole loop continues and you don't add an additional obstacle apart from the obstacle given in the question. This is the implementation of my day 6 part B, and I would consider this as a hard problem. So day 7 is an easier question when compared to day 6 and day 5, because it wasn't straightforward recursion problem. Let's see what it says. So what it says is you are given a total here, and then you just need to use either addition or multiplication to reach this total. Suppose here 10 into 19 is 190, and it's the same for this and that as well. Then you can use both multiplication and addition in the same problem. That is, you can just add something and multiply something, or multiply something and add something, and so on. And finally the result should match with this number, and check if this matches with our result or not. So if you find this row as valid, that you can use plus multiply, plus or multiply, plus and multiply, or multiple pluses, multiple multiplies between them. And if you find this row as valid, then you just need to add the number. You just need to add the result of the right cases, and that's the answer of part A. How do you do it? First, how do you identify that this is a recursion problem? The way you identify something as a recursion problem is here. For each case, there can be two different results. That is, I will just take this example 190 3267. So this is the input we have. So we need to use multiplication or addition to make sure that you reach this result, and first identify whether it is possible or not. Okay. So in each place you can do two different operations, either plus or minus. Here the same, here plus or multiply. The same here, either add or multiply. So if you do an add here, then there is a whole bunch of result you will get here, because if you select an add here, you will get two possibility, that is the next will be an add or multiplication. If you do a multiplication in the beginning, the next one will be an add or an multiplication. So you have four different answers here, that is two space needs to be filled, and there can be four different types of answers which you will get, just 2 square, that is 4. So you can see there is an exponential, the input is less, but there's an exponential output, that is 4. So this is more than enough to identify the problem is recursion or not. How exactly is recursion? Let's draw the recursion tree here. So first I take 81 here, 81, and you can do two different operations here, either add or multiply. If you want to add a number, then you can do 81 plus 40. If you are multiplying the number, then you will do 81 into 40. This gives one result, and this gives another result. That is, which is same as two different possibility here. That is, you can do 81 plus 40, 81 into 40. These two are the two intermediate results. Now after doing that, on top of this result, you can perform two different operations, that is either add or multiply. So you would be doing 81 plus 40 plus 27. You do 81 plus 40 into 27. This will be giving us one result, that is either this result will be 3267. This result should match with 3267. This result should match with 3267. If it matches, I would return true. If this matches, I would return true. And this goes on layer, and finally on top layer I will have either true or false, and then I would return that value. The same with the other half as well. So after doing this 81 into 40, you can either add or subtract. If you add on value, it will be 81 times 40 plus 27, 81 into 40 into 27. So these are the four intermediate answers, four answers you would get, and out of the four you need to check if anything matches with this 3267. So this result equates to 3267, this result equates to 3267. But how do you make sure that the whole recursion and result prints either true or false? So you have two intermediate result which prints true, two intermediate result which prints false. So what we are going to do is, for this intermediate tree here, we have one true value that's been returned, one false value that's been returned, and we are going to do an OR operation on both of them. So true or false, which will return a true here. Similarly, this will return a true, this will return a false, true or false will return a true, and then true or true will return a true, and eventually will return a true. So based on this idea, I was able to identify that we need to do recursion here, and this is a very straightforward recursion. Let me show you how I've implemented this recursion. So the tricky part here is the recursion and nothing else, and everything else is very straightforward here. So what I do is I call the recursion function, and the result is the first number, because we will have the first number, and from the second number onwards we need to make sure we either we add the result or multiply the result. So we do two recursive calls here, one to just add and another to multiply. So for adding, I would just add the numbers. For multiplying, I would just multiply the numbers, and the eventual result of add and multiply, I'll do an OR operation. And the moment we reach the last number, I will look whether if it matches with the input number, that is our total. If it matches, I will return true, else I will return false. And this is very important for any recursive problem, because we need a condition to break out of the recursion, else it will go on an infinite loop. What I mean by I need a condition is this last stage needs to be determined. That is, we've been through the loop, we've been through the tree, and we finally reached somewhere, and we need to return back either true or false for the recursion tree to end. That's what I'm doing here. I've reached to the end until the last number, and I will see if it matches with the output total which we want. If it matches, then this add would return true, or the multiply would return true. That is our two possible combinations, add and multiply, and I'm doing an OR on both of them, and then I'm returning back. This is the solutions for my solution for my first problem. And problem B is a slightly elongation of problem A. What they're saying is they are adding a third operator called this OR. What this OR does is it just concatenates the number. So apart from add and multiply, now we can concatenate number. Take this example 7290. You multiply this 6 and 8, which is 48, and then you concatenate with 6, which becomes 486, and then multiply with 15, you get 7290. So earlier we were able to do only plus or multiply. Now we have a third operation which is possible. It's just an extension of the already existing recursion. Now what happens is what happens is earlier we were doing just plus and multiply, whereas now we have another possibility of doing an OR. The remaining code is exactly the same, but in each stages, instead of two possible outcomes, there are three possible outcomes which is possible on a number. Three possible operations which is possible on the number, and each operation will eventually lead a result, and we just need to do OR on the result and make sure at least something matches with what we wanted to. Regarding the implementation, it's exactly the same. We just add a number, we just multiply a number, and along with that, what we do is we just concatenate the two numbers. How do we concatenate two numbers? I am converting everything into a string here, and then just adding together, and then I'm converting back to an integer. And now since earlier we had two possible results and we did OR of the two result, now we have three possible results and we are doing an OR of all three numbers. The implementation in C++, I had some problems which you can see the test cases. The numbers which they wanted, the tally is huge, which crosses int, which sometimes crosses long. So what I am using here is I'm using something called a long, which can store a whole number, and then while for converting it, I'm using something called stall, which just converts the string into a long number. And then converting a number into string is very straightforward. I used toString and I converted it. This is my implementation of day 7 a recursion problem. This is an easy recursion. If you know what recursion is, this is an easier problem.